time response analysis. Of a system. So first we see what is meant by time response analysis. Time response means variation of output voltage. Sorry, variation of output with respect to time. Is what we call it as time response. How the output is changing with respect to time for a given input. Before going into the discussion, let us try to understand what are the standard inputs that are available in nature or that can be interpreted with the help of a mathematical equation. So if we know how a particular input can be modeled with the help of a mathematical function, then it would be very easier for us to find out the variation of output with respect to time. So we try to understand what is meant by what are the types of inputs. We call these inputs as standard inputs. Simply we call them as standard input signal. So the standard input signals that we use are unit impulse, unit step, and unit ramp. First, we try to understand what is a unit step input and what is unit step function, what is unit impulse function, what is unit step function, and what is unit ramp function. So, first we see what is unit impulse. The unit impulse function is represented with delta t is equal to 1. Its value is equal to 1 only at the time instant t is equal to 0. And other time instants, its value is equal to 0. And it can be represented in a graph like this. On x-axis, we take time. On y-axis, we take the magnitude. And this is the reference point, what we call it as the origin. That is, t is equal to 0. So at this point, this delta t will have the magnitude of 1. So, to have an understanding, I am representing this with another colored symbol. So, this is delta t. And up beyond this point, its value is equal to 0. And this is the 0 line. So, this would be look like this. delta t is equal to 1 and t is equal to 8. This function is known as unit impulse function. Okay. Now, what is the Laplace transform of this unit impulse? The Laplace transform of unit impulse is limit, Laplace transform of delta of t is equal to 1. The Laplace transform of unit impulse function is equal to 1. This you have to remember. There is no other alternative. Okay. Now, let us move to unit stepping. Unit step is represented with u of t and its value is equal to 1 for t greater than 0 and its value is equal to 0 for t less than or equal to 0. So, this function can be represented graphically like this. This is the time axis and this is the instant where t is equal to 0 and this value is equal to 1. And unit step function would be like this. So, the unit step function will have a constant magnitude with respect to time for t greater than 0. Example for this unit step input is it can be approximated in electrical engineering with the help of a DC voltage source whose magnitude is equal to 1 volt can be treated as a unit step input. You know that a DC voltage will have a constant magnitude of voltage throughout the time. The moment the switch is on. Okay. So if the switch is on and t is equal to 0, then its magnitude is equal to 1 as long as the switch is in on state. Okay. So a unit step function is a unit step input is a signal whose magnitude is equal to 1 for t greater than 0 and its value is equal to 0 for t less than or equal to 3. Now, let us try to find out what is the Laplace transform of unit step input. The Laplace transform of unit step input L of u of t is equal to 1 by s because its magnitude is constant. The Laplace transform of a constant is always is equal to the magnitude, the constant value divided by s. So, the Laplace transform of unit step input is 1 by s. Coming to the third signal, the third signal is unit ramp input. This unit ramp is represented with R of t is equal to t for t greater than 0 and its value is equal to 0 for t less than or equal to t. And If you represent this R of t on time scale, this is time. This value is 0 on a horizontal axis, 1, 2, 3. On the vertical axis, 1, 2, 3. So when t is equal to 0, its value is equal to 0. When t is equal to 1, value is equal to 1. When t is equal to 2, its value is equal to 2. When t is equal to 3, value is equal to 3. If you join these points, we are going to get a straight line. Join the points. Or it is represented like this. T, R of t on y-axis passes through origin and we have a slope equal to 1. The slope of the line is equal to 1. So unit ramp's input is a straight line that passes through origin having a slope of unity. Suppose the Laplace transform of unit ramp input is L of R of t, that is equal to 1 by s square. So here, now I am writing the name of the signal, its representation in time domain, and its Laplace transform. The name of the signal is unit impulse. And its time domain representation is delta of t is equal to 1 for t is equal to 0 and it is equal to 0 for t is not equal to 0. And its Laplace transform is 1 by s. The second one is unit step. It is represented with t of t is equal to 1 for a t greater than 0. It is equal to 0 for a t less than or equal to 0. Its Laplace transform is 1 by s. Sorry, unit impulse is 1. And unit ramp is R of t is equal to t for a t greater than 0 and is equal to 0 for a t less than or equal to 0. And its Laplace transform is 1 by s square. So if you observe the Laplace transforms, if you want to get the Laplace transform unit step input, if you integrate the unit impulse function, Laplace transform unit impulse function, you will get the Laplace transform unit step. If you integrate the Laplace transform unit step, you will get the Laplace transform of unit ramp. So these are called as higher order inputs of the system. So if you observe, the order of the denominator polynomial for the unit impulse function is 0, whereas the order of denominator polynomial for the unit step is 1, and the order of denominator polynomial for unit ramp is 2. Okay. Now, let us see natural response or impulse response of a system. So, we know that the general form of a transfer function is the ratio of output Laplace transform of output to the Laplace transform of input is defined as the transfer function. So if g of s is the transfer function of any system, the value of this g of s is equal to g of s by r of s. For unit impulse, its Laplace transform is the Laplace transform of unit impulse function L of delta t is equal to 1. Suppose that if unit impulse is given as input to the system, then the value of C of s is equal to D of s into R of s. We know that R of s is equal to 1 per unit impulse. So, C of s is equal to D of s. To find out the value of variation of C with respect to time, variation of output with respect to time, we need to apply inverse Laplace transform on both sides. So apply inverse Laplace transform on both sides. So inverse Laplace transform of C of t is equal to inverse Laplace transform of D of s. We know that inverse Laplace C of s. Inverse Laplace transform of C of s is equal to inverse Laplace transform of G of s. We know that the inverse Laplace transform of C of s is C of t. So C of t is equal to inverse Laplace transform of G of s. So the value of this D of s is known as its impulse response or natural response. So what is impulse response? The response of a system due to impulse input is known as impulse response, or another name for this impulse response is natural response. Now, let us try to find out the impulse response of a first order system. Since the system is of first order, then we should have only one pole in its denominator, polynomial. So G of S is equal to 1 by S tau plus 1. This is what I am considering. This is called as the general form of first order system. Here we are asked to find out the impulse response. So we know that C of S by R of S is equal to G of S, that is equal to 1 by S tau plus 1. As we are asked to find out the impulse response if the input is unit impulse, then R of S value is equal to 1. Therefore, C of S is equal to 1 by S tau plus 1. We need to find out C of t value. To find out C of t value, we need to convert the factor on the right hand side to the equal to into a form that was familiar to us. The form that was familiar to us, this is 1 by S plus A. The inverse Laplace transform 1 by S plus A is equal to e power minus A. So we need to convert 1 by S plus tau plus 1 into a form S plus A. For that purpose, you divide numerator and denominator with tau. Divide numerator and denominator with tau. So C of S is equal to 1 by tau divided by S tau plus 1 divided by tau is equal to 1 by tau into 1 by S plus 1 by tau. Here A is equal to minus 1 by tau. So you apply inverse Laplace transform on both sides. The inverse Laplace transform of C of S is equal to 1 by tau inverse Laplace transform of 1 by S plus 1 by tau. Inverse Laplace transform of C of S is equal to C of t is equal to 1 by tau into 1 by S plus 1 by tau is e power minus t by tau. This is known as the natural response of a first order system with the transfer function 1 by S tau plus 1. Here, this tau is known as time constant of the system. So, if you plot the characteristic of the C of t with respect to time, variation of C of t with time. We need to take an x-axis time, on y-axis C of t. At t is equal to 0, e power minus 0 is equal to 1, value is equal to 1 by tau. As the time increases, then value decreases, approaches to 0. As the time approximately at t is equal to 5 time constant, value will become 0. That means the value of C of t vanishes to 0 as time is approaches to infinity. This kind of response is known as exponentially decaying response. So, the response of first order system to unit step input. You know that for a unit step, its Laplace transform R of s is equal to 1 by s. So, you consider the general form of Laplace transform of the first order system is C of s by R of s is equal to s tau plus 1. Okay. Now, the value of C of s is equal to R of s by s tau plus 1. Substitute R of s is equal to 1 by s in the above equation. So that C of s is equal to 1 by s into s tau plus 1. Now to find out the value of C of t, we need to apply inverse Laplace transform. Okay. So here, we need to convert this denominator factor into s plus p form. For that purpose, you divide the numerator and denominator on the right hand side factor with 1 by t. This is equal to 1 by tau into 1 by s into s plus 1 by tau. So, this is the value of C of s. So, what is the partial here? If you look at the factor within the brackets, this factor is not in the standard form. So, this is to be divided into convenient fractions with the help of partial fraction expansion. Okay, so I am considering the factor. I am considering the factor 1 by s into s plus 1 by tau. This can be written as a1 by s plus a2 by s plus 1 by tau. Here you apply Heaviside partial fraction expansion method. So a1 value can be found out by doing like this. A1 is equal to limit as S is tending to 0, S into 1 by S into S plus 1 by tau. So this S will get cancelled out. Here, limit S is tending to 0, 1 by S plus 1 by tau is equal to 1 by 0 plus 1 by tau is equal to tau. The value of A1 is equal to tau. Next, let us try to find out. Let us try to find out the value of A2. A2 is equal to limit as S is tending to minus 1 by tau S plus 1 by tau into 1 by S into S plus 1 by tau. S plus 1 by tau, S plus 1 by tau will get cancelled. We are remaining left with 1 by S in the factor, so that A2 is equal to limit as S is tending to minus 1 by tau into 1 by S. So this is equal to minus 1 by 1 by tau is equal to minus tau. So P of S is equal to 1 by tau into tau by S minus tau by S plus 1 by tau. So if you observe in these two factors, in the numerator tau is there. Here we are dividing this with tau. These two will get cancelled. So C of S is equal to tau by tau into 1 by S minus 1 by S plus 1 by tau. Tau will get cancelled out, is equal to 1 by S minus 1 by S plus 1 by tau. Now you apply inverse Laplace transform on both sides. So the inverse Laplace transform of C of S is equal to inverse Laplace transform of 1 by S minus inverse Laplace transform of 1 by S plus 1 by tau. You know that inverse Laplace transform of C of S is equal to C of t. Inverse Laplace transform 1 by S U of t, and inverse Laplace transform of 1 by S plus 1 by tau is equal to e power minus t by tau into U of t. So U of t is common in both the factors, so you can write like this. The value of C of t is equal to U of t. C of t is equal to 1 minus e power minus t by tau into U of t. So this response can be represented point. This is the time axis. This is vertical axis, y-axis. On y-axis I am taking C of t. This is 1. This I am represented with the help of two factors. One factor is this is u of t, and the second factor is e power minus t by tau into u of t. This is e power minus t by tau into u of t. The resultant is difference of these two factors. So, at t is equal to 0, it will be having 0 value, so that value increases exponentially and reaches to u of t. And this is equal to 1 minus e power minus t by tau into u of t. This response is known as exponentially increasing response. So, the magnitude of the response will increase exponentially for a first order system if it is having a pole at S is equal to minus 1 by tau, and the time constant of the system is equal to tau. This term is known as the time constant of the system. I will explain in detail about what is the time constant and how it is defined, how to find out this value, while I am explaining the response of second order system to unit step function. Okay, so I hope you understood the concept. Thank you for listening.